everyone. Are you able to see my screen? So I just wanted to, discuss what we went over yesterday, and I also wanted to check how many of you actually went back and did the deep learning on ramp. So how many of you actually ended up looking at the deep learning on ramp? Anyone? Or would you need more time? Centers? Was there
Yeah.
anyone? Yeah, anyone looked at it?
Yes.
Yeah. Can you please share your experience doing that, or anything that you liked or disliked?
It was a great experience. I didn't know. I mean, it was going to be that good. So
Okay.
very simple, very nicely given.
Hmm.
Most of you have covered yesterday, I suppose.
Yes,
Almost.
yes, yes. Most of it I've covered yesterday. That's correct. So similar to that, you have a basic MATLAB on-ramp also. And in addition to that, multiple multi-day trainings which you would attend, with an instructor. You can do it in your self-paced. We'll send you some information on that, and you can get in touch with me or a few people from my team who I'll pass on the information to, if you want to get more access to that. There are totally 11 courses like that, starting from linear algebra or statistical methods or solving ordinary differential equations and things like that. Okay. Um,
Thanks.
yeah. Okay. Thank you for sharing that. Your name, sir?
Bhuj.
From where, sir?
Bhuj, Kutch, Gujarat.
Okay. And which institute?
It's Government Polytechnic, Bhuj.
Okay. Oh, thank you. Okay. So just to go over what, to recapitulate what we did, the deep learning workflow is essentially taking a look at, getting the data and pre-processing it, define the layers in the convolution neural network, set the training options, train the network, and then test and deploy the trained network. You will end up repeating your steps until the network reaches the desired level of accuracy. More the number of layers, more features, but you may end up overdoing it also. So that's one thing you will have to be careful about. Okay. Any questions on this workflow so far, or any questions from what was covered yesterday? Okay. Now, what I wanted to have as a takeaway is, you can do deep learning for image classification. It uses convolution neural networks. They can have different combination of initial layer, but you will need to have the fully connected layer, softmax layer, and the classification layer. And there are few factors that affect the accuracy and training time. It depends on the network architecture, what the initial learning rate is, and also what the batch size is. Now, there were a few questions. Do we only have to use AlexNet? Should there be only a pre-trained network and things like that? The answer is no. You can do it from your own set of training data. You can create your own training set, or you can add to an existing training set. So we will take a look at that, and that is what is known as transfer learning. So transfer learning with convolution neural networks is something that we'll be going over. So there are two approaches for deep learning. Okay, so one of them is you train a deep neural network from scratch. You take the images. There are learned features which are a part of the convolution neural network, and then you end up performing the classification. Another mode is where you already have a pre-trained network, like how we did, but then you end up fine-tuning an existing model. That is, you have something as the base, and you will fine-tune the network weights in order to be able to do that. That is known as transfer learning. Okay, a question now. Which one is a more computationally efficient approach? Can someone tell me?
Transfer learning.
Transfer learning. Why would it be computationally efficient?
Because we need to change few things. We don't need to calculate each and every thing.
Okay, that's correct. So this is where we end up saying transfer learning helps when you already have training data, which are around, say, 100 to 1000 of the size images, which are optional. The computation is moderate computation. You don't need a graphic processing unit. You can do it on a regular computer. The training time is typically seconds to minutes, and the model accuracy is essentially good. It also depends on the pre-trained model. But if you want to train a neural network from scratch, you will need definitely thousands to millions of labeled images, because they will serve as the ground truth. The computation time is essentially computationally intensive. It will take a few days to weeks. It requires a GPU, so the training time is quite intense. And then the model accuracy is definitely high, but then what will happen is if you end up having smaller data sets, you can perform overfitting. Yeah. So it depends on what your requirement is. If you have a pre-trained model and you have only a few minutes or seconds to perform, you adopt the transfer learning approach. If you want to train the neural networks from scratch where you have your own custom images, then you will need a GPU and you will need a few days at your disposal. Okay. So any questions on these two slides? What are the two approaches? What is transfer learning and what is from scratch? Okay. Now, this is the transfer learning workflow. Okay. We will go over each of the steps that are there in the transfer learning workflow. Transfer learning workflow means you will fine tune a pre-trained model. Okay. That's what we are going to be learning at this point of time. So the first step in the workflow indicates that you load a pre-trained network that is like AlexNet or GoogleNet, where the early layers essentially you learn the low level features in the image. And then the last layers will essentially provide you with the task specific. So what you do is maybe these layers you end up adding. Okay, you load the pre-trained network, but you may add additional layers. So these are already pre-trained and you have these layers. Next step is instead of these violet layers that were there here, add new layers, replace the final layers with newer layers to which will learn features that are specific to your data. Okay, so if you have fewer classes, because earlier what will happen is there are a lot of classes, you saw that there was an overfitting where fish got termed as a hot dog or vice versa, correct? So you might say let there be fewer classifications such that the learning happens faster, give it fewer options. Okay, so replace the final layers. That will be the step 2. The next step will be give your training images and also the training options and train your network. So a few hundred images, a few tens of classes. Okay, and following that, perform the prediction and assess the network accuracy, because you will have the training data with what output you expect. Look at what the training is, and those are the test images. So this is essentially the step where you perform the training. The last thing is essentially use the network to be able to perform the classification. So these are the 5 steps in your transfer learning. That is, load your pre-trained network, replace the final layers with something that's more specific to your application and data, train the network, predict the network and its predict and assess the network accuracy, and then deploy the results. Any questions at this point of time?
No, sir.
No? Okay, good. Now, what we would like to say is the main takeaway from this transfer learning is to be able to replace the last layers with our own layer. It's an efficient way to modify the pre-trained network models to our needs. Okay, and also use an image data store. Yesterday, if you noticed, you were able to see how you can end up pointing to a particular folder and getting all the images from that. That was called an image data store. And also MATLAB lets you visualize the activations in a particular network. We saw that in the neural network toolbox yesterday. Okay. Now, any questions on this transfer learning at this point of time? I will send you an email where you will be able to request for a trial of MATLAB, and also I will send the files here. You can run it on your own. Okay. Rather than me showing it to you, it would be nice if you can run it on your own. Even the deep learning on-ramp has that component. Okay. Now, any questions at this point of time? Okay. The last part is deployment. Can someone tell me what do you mean by deployment? What is that?
Sir, I suppose it is whatever network we trained we deploy some data on that.
Okay. Deployment means, so there are algorithms which are there on your computer which you have designed, but where will they end up working on? Will it always have to be on the computer? No, it may have to be on the autonomous car that you need to drive. It may have to be in, say, another place. Yeah. And it cannot rest on the development machine, which is why we say that deployment is where the actual algorithm will run as a target. Okay. So MATLAB provides a lot of interface in terms of deployment. It connects to, say, Arduino, Raspberry Pi, mobile devices. You can build your algorithm in MATLAB and then deploy it onto your device. In this case, there's a specific thing where you might need to run it on GPU. Okay, so the thing is, you have the process here, which is accessing the data. You use the image acquisition toolbox. To perform the pre-processing, you use the image processing toolbox and the computer vision system toolbox. To select the network, it's a neural network toolbox. To train it, you can use a parallel computing toolbox. In order to be able to deploy it, you have a new product called as the GPU coder, which came in the recent release 2017B. That is, which came in September of 2017. Okay, it will essentially end up generating CUDA code automatically. Okay, because GPU essentially, if, in order to receive high performance, you will need to write what is known as CUDA code. CUDA code is very complex. Okay, but we already have MATLAB code, so why should we end up writing CUDA code? That's our question. This NVIDIA will not run MATLAB code. It will not run C code. It will essentially run CUDA code. So from MATLAB to CUDA is automatic, and that is essentially done using what is known as the GPU coder. Currently, it can be used on NVIDIA GPUs. The CUDA language essentially extends C or C++ code with constructs for parallel computing, because typically you end up using one core, but if you need to do parallel computing, you would need to write the code in a much more efficient way, and CUDA does that, and GPU coder essentially gives you the ability to automatically generate that code. Okay, so you have the MATLAB neural network or the deep learning code, which will be converted into CUDA, which will be deployed on the NVIDIA board. Okay, so I want to draw your attention here. So if you notice, I have the x-axis as the batch size. I have the CPU with a particular graphic processing unit and say 3.5 gigahertz and the frames per second. We are comparing it against other classification algorithms. One of them is TensorFlow, classifying software, Caffe, MXNet, and base MATLAB. Okay, so what do you observe over here as the batch size increases? What do you see there? As the batch size increases, do you see the performance gets better as the number of frames increases?
Yes.
Yeah, yeah. Now, MATLAB is there. This is a base MATLAB with a GPU. But when you use a GPU coder, yeah, which is essentially on the NVIDIA, you see that the performance is at least 3.5 times better than the best possible thing, and at least another 3 times better than the MATLAB, the equivalent MATLAB. Do you see the power of the GPU? Yeah, the number of frames it can process per second. It can process around 3,000 frames per second, which is extremely good, 3,000 hertz. Even your TV, which is the LED or the LCD TV, will have either 60 hertz or 120 hertz. That is the frames. But here, the refresh rate. But here, up to 3,250, you would be able to do when the batch size is around 128. Okay, this is a significant increase, and which is why if you're looking at deep learning for real-time applications, please do consider using the GPU coder. So how fast is GPU coder compared to vision algorithms on CPU? Say fog removal, say a a pilot might need to drive via fog. Around 5 times speed up is there. If you need to look at distance transform on medical images, there's an 8% speed up. If you need to look at, say, stereo disparity or a surf feature extraction, it's significant. It's almost 50 to 700 times. Okay, so the takeaway is GPU coder. You can automatically convert MATLAB code into CUDA code, and you can improve the problem for interference. Okay, so this completes my talk on transfer learning and how you can deploy. Any questions on this deep learning talk that I made at this point of time? No? Okay. So now you will be in a place where you can actually complete your deep learning on-ramp, and it would be very nice if a few of you can actually send me the certificates in order to be able to do that. So today's topic on optimization will cover a few concepts. I will take a look at the time when I have to talk about things, and I also promise that I'll give you around 15 minutes of Q&A. Yeah, but before that, what I wanted to do was a lot of you expressed interest in knowing what are the newer capabilities in MATLAB. Yeah. So let me also try zooming in. I'm going to now show you how you can build a UI or a graphical user interface in MATLAB. Okay. Please do let me know if you're able to see the screen properly. Are you visible, or do I need to make it bigger? This is visible?
Yes, sir.
Okay. So you will need to build a UI in MATLAB. Let's say that. Okay. So the way you do that is known. It is called as an app. Yesterday, if you notice, there was an app here where you could end up performing anything that you wanted, including say neural network fitting or neural network clustering, time series, or you may be able to do say financial time series modeling, or you can do say in if you're a signal processing person, you can look at say how to design a window or how to end up building a filter or a filter designer and things like that. So let me show you one example. Say I have a filter designer app here. Yeah. And so you people like, how many of you know what filters are?
Yes.
You know, you're aware FIR filters and all that, correct? So what you can do is you can say I want a high pass filter. Okay. And I will say I want an IAR high pass filter with say Chebyshev type 1, and I'll say I essentially want an order 4. Okay. And I will say I want it normalized where the pass band is say between 0.3. Okay. And once I do that, when I say design the filter, all I did was I just ended up putting all of these parameters. Did I end up getting, is this a high pass filter? Is it suppressing the low frequency components till 0.3? And then it is surpassing, and you see there is a sort of ripple in the pass band. Yeah. And this is for the order. Say now if I increase the order, let me say I increase the order to 8, you will end up seeing the ripple end up it is much better. If you notice, there's not much ripple here. Is that correct? Yeah. So this is a UI. This is essentially a user interface, and it performs certain actions as I click a few buttons and all that stuff. Okay. We will now see how you can build your own UIs. Is that okay? Yeah. So let's take the example of a simple signal generator. Okay. All I want is I want a signal generator which will generate sine wave, square wave, maybe a sawtooth waveform, maybe a chirp, and then a cosine wave. Does that sound okay? So depending on what I select, it should generate those. Does that sound okay? Yeah.
Yes.
Yeah. Okay. Now what I will do is I will say app designer. That is my functionality in MATLAB. When I say app designer here, I end up getting a new window where I do have a lot of components on the left hand side known as a component library. Let me try increasing the size a little more. Is this better? Yeah. So you have a few components over here in the library. You have what is known as the design view, code view, and all that. We will come to what each of those are. Okay. So what are the components of the UI that I would be needing? What are there on the left hand side? Will I need a plot of the axis? Will I need a plot of the waveform maybe? Is that correct? Yeah. Okay. I will drag and drop that here. Okay. And what I will do is I will say I have this and I want to be able to show it this way. Okay. Next, I want to be able to give a drop down where I give the different type of options for the waveform. Okay. And then I want to be able to update it in such a way that whenever I click the button, it will get updated. Is that clear so far? What have I done? I have put the plot. I have put the drop down where I will choose the waveform type, and I will end up selecting the update button. I will click it whenever I want. So I will replace the text here. So here, if you notice, on the right bottom corner, I have the properties. If I click on each of them, you see what the properties for each of these are. Okay. Now, let's take a look at what happens when I do that. So I'll go to the button and I'll say I want the button to be called update. Okay. And I will also say that I want this font to be bolded. I want this to be say 16. It does it appropriately. Does that sound okay? And if you notice on the right hand side, I have a tree which says app.ui figure. When I click on the update button, it will essentially be that. It's called app.update button. Okay. Now, this drop down here, the title I will say, I will call it as waveform. Okay. And based on what I want, I will give different options. So I will have the first option as maybe sine, the second option maybe as cosine, third option as maybe chirp, fourth option as square, and right now I have 4 options. I'll put a fifth option. Maybe I'll have it as sawtooth. Is that clear to all of you how I'm adding the options? 5 options I have added. I've clicked on this. I've also selected the name as waveform type. I can go here and I can say I want this also to be of 16. I want this also to be bolded, and maybe I want the font color to be say blue something. I can say whatever I want. I can put it in appropriately. Let me say I want this also in say violet. I'll just change. Does this sound okay? Yeah. Okay. Now, if you notice here, when I change the type, this also changed. I have app.waveform type dropdown. Instead, I will say app.wave type. I will call this attribute as app.wave type. I just need to double click. And this one, I'll say app.update. And then I will say app.waveplot. Okay. So what does app.waveplot refer to over here? The figure window. Yeah. App.wave type will refer to the waveform type, and app.update will represent the update button. In the waveform plot, I will say, I'll put in the title as plot of the selected waveform. Yeah. And my Y label is essentially amplitude, and the X label is essentially time. Sounds okay so far? Yeah. And then I will select a particular grid. Maybe I will have it with a very stupid color. I'll put a yellow color. It's okay. And I will also say I want this font to be bigger again, and I want it all to be bolded. Sounds okay so far? Yeah. Now can you tell me what should be the functionality of this UI? Can someone tell me? We have done the layout of this, correct? We have done the layout of this user interface or this app, but can someone tell me what should be the functionality of this user interface?
We will select the wave type and click on the update. It will show the waveform.
Exactly. Okay. So this is a design view. Okay. Now I will save this. I will save this as say NITTR app. Okay, I don't have that file here still. I'm just calling it NITTR app. Okay, now after I save it, this is a design view. Okay, there is also a view called code view. So I can click on that. And if you notice, there's already existing code that is written based on the positioning of each of these. Okay, there's already some code here. It says, I have the, the drop down label is say, right, it is font size 16, the position is so much. And then I have the other options here. I do have say the type of the selected waveform and things like that. You see all of that. This is automatically generated. What are the items in the wave type and all that stuff. Is that correct? Yeah. Now, what we will do is, does everyone agree that when I push this button, the plot should get updated? Is that correct? Yeah. Okay. Now, when I go to the code view, I will have to click on what is known as a callback. It says add a callback function to make my app respond to user interaction such as button click. So I'll say add this callback. I'll say the update. I will choose that update is my thing. It's app.update. So the component is update. When the button is pushed, okay, perform some action, and that's particularly the MATLAB code. So what will be the operations that will be performed? Everyone clear with that? Yeah. Why I need a callback? Yeah. Okay. Now, what I will do is I will write my usual MATLAB code. I will say t equals say 0 in steps of 0.1 to say 6 pi. Is it going to be a time waveform? Yeah. So what will be the output when I have to type sine? Will it be sine of t? Is that correct? Everyone agrees? If when it is selected as sine, when it is cosine, it will be y of cosine t. It will be y of chirp. How do I define chirp? It will essentially be sine of t square, but I need to take pointwise multiplication. And then the third one will be fourth one will be square of t, and the fifth one will be sawtooth of t. Is this the code? Is that correct? Okay. Then what I will do is I will have to plot it on this wave plot. So I'll have to go and say plot app.wave plot of t comma y. Everyone understands? So on that particular plot, have t on the x-axis and y on the y-axis. So that will be the plot that you will need to perform. Okay. Now, can you tell me how will we select which one it should be when? Is everyone clear so far? Is this the regular MATLAB code that you might write? Yeah. Now we will have to select which y it will choose. So depending on the option that's selected here, you will have to say whether it has to be a sine wave or a cosine wave or a chirp or any of those. How will you do that? Can we put a switch case? Everyone agrees to that? Yeah.
Yeah.
But you need to find what the app.wave type value is. Okay. Because there is a value that is changing. So I will say here my waveform type equals app.wave type dot value. It is in the object oriented notation. Okay. Then I'll say switch waveform type. Okay. Then I'll say case. What case will be the first one? Is it going to be when it is sine? So let's go take a look at it. It is sine here. So I will say when the case is sine. So let me just indent it fine. Because this is what will essentially be the way you will write it. Okay. Next, you will say case when it is cosine. Okay. And what I'll do is I will just tab it accordingly, and I'll remove these two lines. Just trying to make sure that it is indented fine. The third case will be when it is a chirp. Okay. Fourth case will be when it is a square wave. And the fifth case will be when it is a sawtooth. Note that this name should be the same thing that is there over here, what I have written. Okay. And I've done that, and I will type end. So let's do this. Everyone clear with this so far? Any questions on this? This is essentially the same MATLAB code that you type, except that you're getting the wave type from the object. And then finally, you end up putting in the values the way you wanted to. So how many lines of code did I write here? Around 15 lines. Is that correct? That's all I had to write. Okay. So now whenever that update button is pushed, it will perform this analysis. Okay. Now let's see this in action. I have saved it. I will go here and I will say save and run the app. Let me run it. Okay. And now I got the UI. Okay. And what will I do? Can I select one of the options? Let me say square, and I will hit update. Oh, it says no appropriate method. Interesting. Let me take a look what that is. Let's see why that happened. It should typically work. I'm as surprised as you are. Okay. App.wave type is what this is. Wave type here is this. And let's just check what this is. So I can see what are the attributes that I have here. Okay, it has to be a capital V. Note that MATLAB is case sensitive. I put in a lowercase v. That's why. So when I do that and I say I will select square, and I'll say update. Did I get a square wave? Yeah. Let's see a better waveform, sawtooth. Did I get a nice sawtooth waveform? Or when I do a cosine, you see that it starts at 1 and it goes. If I do a chirp, the instantaneous frequency is increasing with respect to time. And when I do a sine, I get a sine. How easy was this an easy thing to do? Yeah. Okay. Now, do we want to keep updating every single time, or would it be nice if we ended up, when we selected, it should end up updating? Would that be nice? Yeah. So what you do is, we will say add another callback. Okay. And the callback here is wave type. And we'll say when the value changes, execute the same thing. That is, evaluate the same update button push, the same function. And I'll say okay. Okay. Now, when I run this, the first time I don't get anything because there is no startup function yet. I will say update, but now I don't need to go and keep clicking update. It just changes as is. Okay. So this is how you build an app. Okay. Say you wanted some function to be executed initially whenever the figure opens. You can say UI figure and the startup function, and it will be a new function. What we can say is, we will say we want the time to be represented this way, and we'll say we don't want we want the sine wave to be essentially shown. So I'll say y equals sine t, and then I'll have the same plot. Okay, so I'll have the same plot here. I will save it, and when I run, so when the app begins, it always begins with a sine plot, and as I change it, I'm good. Do I need this update button now?
No.
I don't need the update button, so I can go here and I can say remove the update button. It will end up creating everything the way we want it. Okay, it still has update button push. That function name can get changed if you want. You can say wave type changed. You can call it whatever you want, and it will end up getting changed automatically. Okay, now when I run it, I have the waveform showing up. I will change it. It just changes the way I want it to. Is this clear? Is this good enough? Yeah. Any questions on this? No questions? Okay, great. So I wanted to show you this app building as an exercise, because this is a nice way to teach students a few concepts also. Because I'll be sending you a couple of apps that you can use to teach your students, especially concepts of sampling, or say how the electric field varies around equal charges and things like that. Okay, so that essentially is a little bit on app designer that I wanted to talk to you about. So now let's get into optimization. Okay, so I would like for someone to tell me, what do you mean by optimization?
Sir?
Yeah.
So how this app is different from the normally when we are using the wave from command window, writing guide at all?
Guide is the older version. App designer is based on object-oriented programming. So guide is essentially, we do not recommend you to use guide because it's a little more difficult to use than app designer. Plus app designer, since it uses the object-oriented thing, it's easily deployable as a web thing also. If you have your own server, you can have a website where you can house this app. Okay. So it's almost the same way. Okay. Another thing that I'm going to do right now is, this app I'm going to be taking and I will say, I will package it. Okay. I will package it. I will call it as NITTTR waveform generator. Okay. I will say the author was Viju with NITTTR attendees. Okay. And I'll add the main file, which is essentially my NITTTR app. Okay. It will check if you need any files here. I'll put my email and all that stuff. What will happen is, when I package it, or I can put a screenshot also if I want, when I package it, it will essentially give me what is known as a MLAPP install. Okay, it's a MATLAB App Installer. So I will get a new thing called MATLAB App Installer. Now what I'll do is I'll right click and I say install, and it will say, will it get installed into my apps here? And it did it here. And when I go down here, do you see there's a new app called NITRIPLETR waveform generator? Is that right? And it shows what the file is. It can give the description. And when I click on that, of course, I have to go to a different folder. Maybe let me go to this folder. I will go to this and I will start that out, and I get the same app. So I don't even need to go and open that app. It is there in the MATLAB app window itself. Okay, so you can have, like for students, how you want to end up having apps, chapter 1, chapter 2, chapter 3, you can build a lot of apps that way. You can have it as a list too. Okay, any questions on this? Okay. Can someone tell me, what do you mean by optimization? We are switching over around, we'll spend around 40 to 45 minutes on this. Can you tell me, what do you mean by optimization?
Best solution.
What's that?
Best solution.
Best solution with respect to what?
Any problem which you want to maximize or minimize.
I didn't get you. What was that?
Anything which we want to maximize or minimize.
Okay, sure. So let's take a look at that. Before that, I want to show you a few scenarios that essentially shows what optimization is. Okay, so optimization problems could be, how do I maximize my fuel efficiency in a vehicle? Yeah, or in financial trade, how do I minimize my risk? Or how do I maximize my profits with respect to a thing such that I can have a good vacation? Okay, now the design process in optimization essentially is the following. I have the initial design variables, which are called my parameters. There is a system. Okay, I have a set of objectives with respect to what I want to be able to meet. If the objectives are not met, I go back and modify the design variable. Okay, otherwise I would say this is the optimal design. Okay, is this process clear to you guys? Yeah. So what does the optimization depend on? Does it depend on the initial design variables? Is that right? And also you need to set the objectives. Yeah, and based on the initial design, it might take a longer time to approach the optimal design based on the modification, or you might be lucky and you might get the optimal design right away. Okay, so why use optimization? Okay, so I have a parameter here where essentially I want to find the hottest spot in, or hottest thing in this pressure ratio where I have revolutions per minute. I want to be able to identify at which revolution per minute and which pressure ratio I have the hottest. How would you ideally do this if you were to do manually? How would you do this if you were to do this manually at this point of time? Any idea?
Initial difference.
You take the initial guess, you move it x and y, and in the right and in the x direction and the y direction. Is it always possible for you to get to the right point? You may get misled and you might go in the opposite direction, correct? So that is not possible. Instead, if you end up doing it using optimization techniques, even if your guess is somewhere, you might be able to take an informed guess on which direction you might need to move and be able to find what the optimal solution for your problem is. So in this case, what are the design variables? The revolutions per minute and the pressure ratio. And we need to find what the optimal solution is. Okay, so why use optimal design? So optimization, it's to find better or optimal designs. Okay, and for faster design evaluation. It is also useful for trade-off analysis, and a lot of times the computers think better than us, so non-intuitive designs can also be found. Does that sound okay? Okay. Now, I'm going to be going over a couple of optimization problems and how you can end up using MATLAB to do those. Each of those is there in the form of a script. I'm going to be showing you the problem, and I will switch to the MATLAB script for that. And we will go over it, and then you will ask me if you have any problems. Okay, so the least squares minimization. Can someone tell me what this here does? I have a curve fitting demo. I have some data t and y, and I want to be able to fit it to that form. Can someone tell me what you mean by this? Anyone?
We initialize the coefficients given any coefficient,
Mm-hmm.
and then we will find the error between the points and the whatever the line we get.
Mm-hmm. Okay.
Our objective is to reduce the technical error.
Okay, sure. That's correct. So what we will do is we will essentially, okay, of course, we'll open up MATLAB here. So I'll close a few windows that I have. Um, Always a good practice to save a few things before you do it. So I have optimization, and I will just run my setup in such a way that I'm able to, see what I want to be able to do. Okay. So the first thing, I have a few examples here. We'll go over 4 of them, but I'll send you all of them. So I have the least squares curve fitting. Okay. So let me know when you're able to see it, or would you like me to show it as a live script? What would you prefer? Is this form better, or would you like to see it as a live script? Live script? Okay, let's go to that. Let me say save copy as. I will probably do at least square minimization. I'll save it as a live script. And there you go. Is this better? Yeah? Okay. What is the first step in the process for me here? I have the data. I have the T and the Y data. I'll run that section in advance. I will plot the data. I got the plot that I wanted. Now, what do I do here? I will say it looks exponential. Let me try to see if it is essentially correct. I will title it accordingly. Okay. And then I'll say, I will have the problem as linear in coefficients. So let's set up the equations. So I have E, which is essentially ones of that and exponential of minus T. So let me run that section in advance. So I have E, and I have the exponential of minus T. So this is essentially what my initial thing is. Now, I will need to see which solver to use because this is an optimization problem. I'll need to check. So the best way is to look at, say, docoptim. Okay, and then it opens me the documentation for the optimization toolbox. So it will show you, getting started or how do you end up the problem setup. So it will essentially say, what are the let me go down here. I will say optimization problem setup. So the first step is choose an optimization solver, then create an objective function, create constraints, set the options, and call the appropriate solver. Now, what we do over here is how do we choose a solver? Let's take a look at it. This optim tool, which essentially ends up giving you what the solver should be. Okay, and you have topics on which algorithms to choose. So let me look at the optimization decision table. So okay, so over here, if you notice, let me try to, sorry, it should have, I know it's a little small, it's a little smaller, but I just wanted to give you a feel of what each of these is. So do you see what is this table here? Which one what does it correspond to? Constraint. And then what does this correspond to? Objective type. So depending on how the constraint is and how the objective is, you can choose which one to solve. Say if it's a linear programming problem, sorry, a linear constraint with an objective type which is also linear, you can say linprog. Okay. If it is say discrete, you can say int linprog. So you do have multiple things. In this case, we want to do a least squares. You have what is known as ML divide. Okay, I just need to click on ML divide and it's essentially backslash. Okay, so that is a solver we will use here. And when I run that section in advance, I essentially end up getting the coefficient, which is this way. So all I needed to do was I have my E, which was essentially what the equation is. And then essentially I'm trying to see if it is an exponential solver. And then I just said E backslash Y. Okay, because CY equals E. Okay, so C equals E backslash Y. Now, let's try to check the fit. So I'll run the section. And if you notice here, did I get a good fit? Yeah, so let me try to change it and you will see. Is this a good fit that you're able to see? Almost? Is that right? So in this case, you didn't need to perform a huge fitting thing. So all I did was just took the error function and then multiplied it. Sorry, I took what it was and I multiplied it with C, and you saw what it was. Okay. Now let's run an advance. So what about constraints? Okay. We will need to check what the constraints are. So we didn't do what the constraints here were, but say if you had a particular constraint, what would it have been? Okay. Let's say the constraint was linear. So let's use LSQ-lin. So we're using LSQ-lin. We will say the constraint is LSQ-lin, but we do have an intercept at 0.82 where the value is 1, 1 and the B equivalent is 0.82. And the coefficients change. Okay, so I will run this section. Okay, and you see that I have put in something here saying I have the optimization options. I want to be able to use LSQ-lin, that is the thing, with an algorithm which is an interior point algorithm. And then I'll say LSQ-lin do that for the value E, Y. I don't need few other parameters. There is a syntax for that. I can select that by saying help on selection. So this will essentially show you how you set the parameters. So in this case, I have set all the parameters that are there over here. So I may not have had D over here, which is why I might have had a 0. I might not have had this AX less than B or this. So a lot of the parameters here are null matrices. Okay, so there are syntaxes for that. So essentially what I will have here is E, Y, and my starting point is 1, 1, and my output is Y, and OPT is essentially the optim options. And I got the new fit, which was essentially over here. So now it essentially ended up saying, you know, we found the minimum that satisfies the following constraints. Okay, and C new is this. So now let's try to fit that C new, EF times C new, what it is. Let's try to do that. And is this good enough a plot? Is this a good enough fit? Yeah. Okay. Now, maybe if you wanted to choose a different algorithm, you could have chosen it there. So there are different ways you can actually set the optim options. So you don't need to essentially end up saying this is the value that you want. Okay. And over here, it actually shows you what are the syntaxes that you can get while you're typing it. Okay. So that's a basic way you end up doing an optimization problem in MATLAB. This was a least squares fitting problem. Okay. The next question is, how do you do it as a system of linear equations? Yeah, this essentially was the same thing. That is, what I did was I have 0.8 to 0.7 to 0.63 this one. So I put it this way, and I said my first column is 1, and the second column is e to the power t, if you realize, and C1 and C2 are what we need to find out. Okay, so I had y of t equals C1 plus C2 e power t, or I'll have it as 1 e to the minus t C1 C2. So essentially over here, I'm doing this sort of a problem. And we cannot solve this exactly because there's 6 equations and 2 unknowns. So are you clear with how we worked on this problem?
Yes, sir.
Yeah, okay. I'll send you these files, and when you look at it, you will be able to see much better. Typically, we like to do a hands-on. You know, we can also discuss if there are options for us to come and do a hands-on in a few of your different institutes. Okay. The next problem is nonlinear optimization. So not always you have the least squares minimization. So let's take a look at this. Can someone tell me what is this picture? Or what is this problem? So how many x's do I have here? 3 x's, is that right? X1, X2, and X3. Yeah. Is this a surface plot? Yeah. And I'll need to find the minimum of where X is, correct? Yeah. And is this a pretty difficult problem because I have to look at in 3 dimensions?
Yes.
Yeah. And it's a nonlinear thing. So how do I do that? So let's take a look at that nonlinear optimization problem. Okay. I will end up again saving it. So you will see that the same thing I don't need to always end up writing it as write a new script, but instead I can end up calling it in the form of a live script. Okay. What I will also do is have my output come on the side itself. Okay. So I would like one of you to actually walk me through the answer here. It's easy. So can someone tell me what's happening? There is enough details over here. So what do I do first?
You're defining the objective function.
Create the objective function. So I write it as @x. It's an anonymous function. I create that whole function here. Is that correct? So I can execute it by say just ending up typing or clicking on the side here. I can run that particular selection, or I can say run section. Let me run in advance. And now what will I end up doing? I'll plot the objective function. Let me run and advance its section. So did we get the plot that we wanted? Is that right? So essentially I created a mesh grid in that value and I'm getting Z. I'm varying X and Y. So if you notice, I have my values for X and Y between -2.5 to 2.5. And then I'm evaluating Z at each of those values. Okay. And this is how my Z looks like. Clear so far?
Yes.
Okay, good. Now, next, what do I need to do? Do I need to specify what my constraint is? What the lower bound or upper bound is? What is my lower bound here? -2.5 with respect to x1 and x2. And even upper bound is also 2.5 to 2.5. Is that correct? It's -2.5 to 2.5 x1 and x2. Okay. Now, what will I do next? So I've set my objective function. I've got the objective function. I also have my constraints. Is that right? So now I need to set the optimization option. So take a look here. So what do I have here? Can someone tell me? I have the options. I'm going to be using the function called optim options. Let's see what the help on that says. Optim option essentially says I need the solver name. What is the solver that I'm going to be using here? Can someone read this out for me? fmin_con. fmin_con essentially corresponds to minimum constraint. So I can click on that and I can say, find the minimum of constraint nonlinear multivariable function. So as we said, it's a constraint which is linear, but the objective function is a nonlinear type. Okay, because it was a smooth nonlinear. Now, what is the next option that I have? I have some name. I display the iterations that I want, the number of iterations. I also define the output function. I will say I want to keep plotting it as it does. All I do is I'll say fmin_con, look at the objective function, which is essentially that function. And this here corresponds to the value that I want to take between -1 and 2. And I have the upper bound and I have the options here. Okay. So can I run, when I run this section, should not, okay, sorry, this did not get executed, sorry. Run this section and then run in advance and let me run that. Okay, so now if you notice, here, I found the local minimum which satisfies the constraints, and it also plotted. It started somewhere here, but are you able to see that it moved around? Is that right? Yeah. So let me just show you. So it was able to plot every time how many, what was the minimum thing, and it moved around and it got it. Okay. This might actually be better when you see it in the in the actual editor. So let me show you that. So in the way the actual MATLAB file was. So let me run and advance, run and advance, run and advance. Okay, I have this here. Let me run and advance and I'll do that. So it was really quick. I could not even see what it was. So it was really quick. So it didn't end up showing me what it was. So that's fine. Now, what I will do is, it says it found the local minimum that satisfy the constraints and then dropping the criteria details. And it said the number of function evaluations. How many did we have? 69 of those. Okay, now what we will do is we will see what the finite differences is. It will show all the points evaluated by fmin con, and we'll see how that runs. Okay, you see all the points that it evaluated. Is that right? So it showed all the points where it was evaluating. Are there a few wrong points also? Is that right? It went away. Then it realized that it had to go back and closer to this. So there were a few cases where the evaluated point was also incorrect, but it was able to take the right decision back. Okay. And now what we would like to do is maybe let's try zooming in and see what essentially happened. In those points, you essentially do not get what the finite difference thing over there is. Okay, you can also end up optimizing it with a user supplied gradient or any of those. So you can say a user defined function. How does that run? So let's run that section. So when you end up doing a user defined thing, it essentially only ended up taking overall around say 18 components as opposed to 69 components. Okay, but this is based on how your user defined thing is. So in this case, I used a Hessian function. Okay, but you can say that I know this is how it's going to be, and this is what I would like to do. Okay, and finally, what I'd like to do is, so instead of using the actual MATLAB function, you can write a symbolic math. So I define symbols x1 and x2. I define my function in the form of x1, x2. I say g and h are gradients, and I say convert the symbolic expressions into MATLAB functions in terms of x1 and x2. So each of these are x1 and x2. And all I do is optim options, fmin con, and say it's a Hessian, user supplied function is a Hessian, and you specify the same bound. Okay, it's exactly the same way, but it's much easier to do it when you have symbolic math expressions. Okay, as I mentioned, this is just to show you how you can set up the problem. We will send you all of these files. Lini ma'am said she would be able to give your email addresses. If you're not able to, if you don't receive it by the end of the week, that is by tomorrow, please do send me an email. I will tell you what my email address is. Yeah. Okay. Any questions so far? Okay. Sure. I want to be able to do one small exercise before.
Excuse me, sir.
Yes, sir.
Sir, I am from Rustamji Institute, BSF Tekanpur.
Okay.
Sir, I have some queries. The query number one: if our objective is quadratic in nature, can we use the fmin com for solving it?
If your objective is a quadratic in nature, yeah. If it's a smooth nonlinear, yes, you can use fmin con. Yes, because it's a smooth one but nonlinear. Yeah.
Okay.
It can be used. Yes.
Which one is better, sir?
Which one as in fmin con or
Quadratic equations.
for quadratic equations? You can use both. You can use either the quadratic programming or you can use the fmin con. Either of them. If you know it's quadratic, you can use the quadratic programming. Okay.
The result will be same or not, sir?
It depends. It depends on your data and what your starting point is and what the constraints are. Okay. Yeah.
Another query, sir. Since various optimization techniques are available,
yeah.
But for the trade-off analysis, which one will be the better?
Again, that depends on the starting point that you choose. What are the bounds and many other options. We cannot. We will have to take a look at the data. Okay.
Okay, sir. Thank you very much.
Okay. Good questions. Any other question? No? Okay. Great. I want to be able to take a little bit of time to look at one of the problems, which is essentially, so I'm going to skip one example, which is the nonlinear optimization where I have the gantry crane. But what I want to do is I want to take a look at what the mixed integer programming, it might be mixed integer. Let me take a look. Yeah. Okay. So I want to take a look at mixed integer programming. The mixed integer can be where you have many quantities that exist in different discrete amounts. It won't be partial values. It may be shares in a stock or the number of cars that a factory produces or number of cows on a farm. You cannot say it has to be 2.5 cows. Yeah. Or you may have binary decision. So it would say buy or don't buy, or on or off, the business decision that you'll have to take. So the mixed integer linear programming, it will solve optimization problems while enforcing certain variables need to be integers. That is what we call as mixed integer linear programming problem. So either yes or no, on or off, etc. Yeah. So you have continuous and integer variables. So in this case, you may have something which will be any value between 1 and 100, or it has to be exactly 1, 2, 3, 4, 5. Okay. Or you can also have linear objective and constraints in such a way that minimize this with respect to these sort of conditions. Okay. So we are going to be taking one example, which is called as a traveling salesman problem. Does anyone know what is a traveling salesman problem is? Can someone tell me that? Anyone in the center?
Minimizing the distance traveled.
Minimizing the distance traveled and also the number of points and all that. So it's sort of the minimum spanning tree that we look at. So what will happen is, say there is someone who has to travel to Delhi, Chennai, Chandigarh, Kolkata, Goa, Bombay, Mysore. Yeah. So doesn't make sense for him to come from Delhi to Chennai, go back to Chandigarh, then go to Goa, then go to Kolkata, then go to Bombay and all that. It doesn't make sense. No. It will try to find what the distance shortest path is. So between from Delhi, he will go to Chandigarh, Chandigarh to Kolkata, Kolkata to Goa, Goa to Bombay, Bombay to Mysore, Mysore to Chennai. Is that a shortest path? So what it will do is it will calculate the distance between a combination of all points, and then it solves an optimization problem where the variable correspond to trips between the 2 points. Okay, this is essentially the traveling salesman problem that we have. So I want to take one example where we're going to be looking at what we have as, say, where we would like to do a shortest closed tour, with a set of stops. So I'm going to be looking at where all I have MathWorks offices in the world. Okay, and I'll try to see what the best way to go about it is. For this, I'm also going to be using what is known as the mapping toolbox. Okay, so the first thing is I'm going to be loading where my office locations are. I will mark it appropriately, and I will show you what where it essentially will end up having the location. So let me run this section. So this will essentially take a list of locations from the latitude coordinates. So if you notice, we have 3 locations in North America. In India, we have locations in Bangalore, Pune, and Delhi. We have offices in, say, Shanghai, Beijing, Tokyo, Seoul, Sydney, and many offices in Europe. Okay. By looking at it, you know that you will do from Bangalore to Pune, Pune to Delhi, Delhi to Bangalore again. That is one thing. But how do we automate it when there are a lot of points? So that will be my takeaway for this problem. Okay, so I've done that. Now what I'll do is I will try to see how many possible paths are there. Okay, and I will say these are the number of paths. So let me just end up docking it into my editor window. So let me do that. So it essentially says I have these many possible paths. So I can end up doing almost, say, 4 followed by that many zeros in terms of what I have the paths that are over there. Okay. Now I will formulate the problem. So I will look at what are the all the possible trips that are on all distinct pairs of stops. So can someone tell me what will be the all possible trips value in terms of permutation or combination? If I have 5 cities and I want to form pairs of 2, is it 5C2? Is that correct? Yeah. So, and I will calculate the distance for each trip. And the cost function is to minimize the sum of trip distances for each trip in the tour. Okay. So the decision variables are of course binary, and the tour includes every stop. Okay. So this is my constraint. So let me minimize this as well, just so that you're able to read everything. So I've given enough inputs, constraints, everything. So the thing is, I will generate all possible trips. I'll calculate the distance for each trip. the cost function is to minimize the sum of trip distances. So I don't want to go from Delhi to Bangalore and back to Chandigarh, correct? It should be Delhi to Chandigarh and then to a different point. That is my cost. The next thing is the decision variables are binary. Okay, so it is either a yes or a no, whether the trip has to be 1 or 0. Okay, and to ensure that the trip includes every stop, you need to ensure that a linear constraint that each stop is on 2 trips. So there has to be to Bangalore and from Bangalore, to Delhi and from Delhi. Is that correct? Do you guys agree with that?
Yes.
Yeah. Okay. And finally, so what we'll do is we will say 37 stops, 351 trips, so 351 binary variables. So essentially 27 C2. So we will generate all the trips that are there. That will be my indexes. Okay. And then I will create all the distances that are there. I will try to check what each of the distances is in terms of the ellipsoid, and then what the distance is. Okay, let me run that section. Okay, and then with this definition of the distance vector, the length of the tour is essentially determined by saying dist of x, where is the solution vector. So let me just run that section. I'll advance. Then I have equality constraints. So I have 2 types. So the first thing says that there must be only 27 trips. That is one constraint. And then the second thing is each city has 2 trips. Okay. So I will say that I want to see what the overall number of trips is and overall number of stops. And let me run that section and I will advance. And here I will say that for A equivalent, so what the number of trips are, and find which trips include the stop and where each of the indices are there. So I will run that, and all the decision variables are binary. So I will set the initial condition there to an appropriate thing. And then I will optimize using what is known as int-lin program, because it's an integer linear programming. So all while what I set was I set my constraints to A equivalent, B equivalent, lower bound, upper bound, and the overall optimization thing that I need to do. So I will run that problem. Okay. And then let's visualize the solution. So now if you notice, it gave me a thing where it makes sense for me to travel within the US. Okay. Again, within India, within China and Japan, or within China and Korea, and then maybe Japan to Australia, and within a few countries in Europe, and again within Europe itself. So I can zoom in and see what was the thing that it gave me. So it said, you know, these are close by. So say Brussels, Antwerp, and these are close by, finish it in one trip. Few other things say go from Paris to London, London to Glasgow, then from there go to Stockholm. So it essentially gave me that. And here it said, maybe you start in Bangalore, go to Pune, Pune to Delhi, and then come back to Bangalore. Everyone agrees with how this programming thing worked? Was it fine? And one more example here was it said 3 offices in Japan, finish them all at once, and then finally do Australia. It may also have given this set here, but then there's already a longer distance. So that is essentially what. And the solution has multiple subtours. Okay. And the constraints specified do not prevent these subtours. So let's see how to. Can you mute it at your end if you're having parallel conversations? Okay. So I have this sub constraint, and I included the non-linearity constraints over here. And essentially, I say that I do not want, the number of tours. There should be only one subtour. I don't want more subtours. So perform the same thing, and let's take a look at the solution quality. So this is still this. Let's run that thing, and okay, it did not give me what the. So okay, I don't have what this. Okay, I might have missed doing one particular section. Apologies for that. Okay, let me run in advance. Run in advance. Sorry. Run in advance. Run in advance. So this was the solution that I gave. Let me run in advance. Subtour constraints. I've included this, and I have my output. So Okay. I have something that's missing. Okay. I do have the length of subtours. So is there a value there? Okay. There's some issue here. I'll take a look at it and pass on the right files to you. There, it doesn't recognize this output numtours. I'll see why the reason for that is. But do you understand how this turned out to be an optimization problem? You essentially gave it integral constraints, and you said each place had to have some form of a entry and an exit point. Okay. There are more examples which are there in this, which I will essentially send it out to you. You have a global optimization. How do you do genetic algorithm, and also how do you do a pattern search and things like that? This will be sent to you so that you can evaluate. Okay. So what I want to actually show you at this point of time is a couple of things. Okay. So before I can open it up for questions, I want to be able to show you a couple of things. So a lot of you may not have access to MATLAB. So you can say MATLAB trials. So I'll send you this link, and it's a free MATLAB trial which you will get for around 30 days. It will have multiple toolboxes. Can it be muted at some point, please? Yeah, thank you. So you do have multiple toolboxes that you can actually end up getting in terms of trials. Okay, for some reason this gave me this things I'm on a smartphone with a high resolution display, but you can end up
Excuse me, sir. Good afternoon, sir.
yeah.
Yes, sir. You were talking about a traveling sessional problem. Sir, I just want to know that what is the better procedure to calculate minimum distance between points by backtracking or dynamic programming?
By what were the two options?
Dynamic programming or backtracking?
How many points do you have there?
So, suppose we have 10 points.
Okay, it will again, meaning there is no right answer or what's the best thing for any optimization problem. It depends on your data and your constraint. Okay, so you will have to look at how it performs. There's never a best option because it depends on how your constraint is, what your desired result is, and only then you will be able to get that. Okay.
But sir, according to
Yeah.
time complexity, we can identify which one is better.
According to what?
Time complexity.
Yes, of course, with respect to time complexity, you would be able to run the tick-tock function and you can see which one fares better. Yeah. And also in terms of the number of iterations taken and things like that. But again, you will have to end up evaluating it on your data. Okay. I don't want to give you the wrong answer saying the dynamic works better on this sort of data. Okay.
Okay. Thank you, sir.
Okay, sure. So as I mentioned, I will send you this link. You will be able to get a free MATLAB trial around 30 days. And what you can try out is I'll be sending you this entire folder, which will have all the MATLAB code that is there for each of the examples that I gave you. So it has functions that are there and all of that. So this will be sent to you. Okay. In addition to that, yesterday, all the scripts that we did are a part of that deep learning on-ramp. Okay, everything that was there, but we will be sending you that presentation as well. But do complete this deep learning on-ramp if for you to be able to understand things much better. Because one thing that I will always tell you is that it makes sense for you to try out things hands-on rather than listening. So we'd like to ensure that you are able to perform a lot of hands-on stuff before you can actually end up using it in your research problems. Okay, so the deep learning on-ramp, as I mentioned, till using pre-trained networks, you can do it, and after which you can perform transfer learning and also evaluate the network performance. Okay, a couple more things that I want to point out to you is MATLAB, of course, is great for deep learning. Yeah. If you're in India, of course, a lot of you are in India, we have our flagship event called MATLAB Expo. I think Hyderabad and Pune are closer to you. It is held on April 24th and April 26th. It has a wide variety of talks by both industry and by MathWorks people. So I can show you the agenda for Pune. So it will essentially end up showing how MATLAB is ready for artificial intelligence, what's new in MATLAB. And there are 4 tracks. One of them, that's data analytic applications, control systems, signal processing systems, and robotics and autonomous systems. So these are things by MathWorks people. There are few industry and education customers also presenting. And then in addition to that, what is also there is there are hands-on workshops, hands-on workshop for deep learning, hands-on workshop for multi-domain system modeling, and an automatic grading framework called Cody coursework within MATLAB. Okay, so excuse me, that is one thing. Another thing that you can use is when you go into MATLAB, you have something called MATLAB Academia. So you can say for educators, when you click on that, you actually end up seeing, of course, auto grading MATLAB code. You can talk to me on that. You have an option of accessing MATLAB online, but what is really nice is this MATLAB courseware. Okay, you can actually look at courseware that is pre-built for